Hello Year 10 and welcome now to exercise 6C, which is an extension on what we learnt in 6B, because in 6B we talked about congruence in triangles. Now we're going to go to congruence in quadrilaterals, four-sided shapes. Now it doesn't matter whether there's three sides or four sides, it doesn't matter how many sides there are on a shape. If the shapes are congruent, that means that they're identical. That means that all the side lengths are the same and the angles are the same, so they're the same size and the same shape identically. You'll have matching or corresponding sides that will all be in the same length, and the angles will match up with each other and be the same size, the same angles. Remember that if we're talking about congruence with shapes, it's three horizontal lines, and there's also a term that we need to learn that's called bisecting something. If we bisect something, we're cutting it in half. So if you bisect a line, you cut the line in half. If you bisect an angle, you cut the angle in half. So bisecting means to cut something in half, and we're going to be using that concept a little later in this exercise. So let's get into some of the examples. Now, let's make sure we understand what the question is asking first of all. It says for part 1, exercise example 1, part A, it says opposite sides in a parallelogram are parallel. Well, we knew that. But it says prove that the opposite angles in our parallelogram are equal. Well, the first thing we're going to do is draw a parallelogram. And you'll notice, because it's a parallelogram, I've got my markers to say those two sides are parallel. A to B is parallel to C to D. And I've got my markers here to say A and D and B and C are also parallel. And I've put on the letters A, B, C, D so that I can actually label things much easier. So there's my parallelogram. Question says the opposite sides are parallel, so I've marked that on. It says prove opposite angles are equal. So what we actually have to do with this question is prove those two angles are equal, and we need to prove those two angles are equal. So that's ultimately what we're heading towards. Now, the first thing we're going to do when you deal with questions like this is try and create triangles if we can. So I'm going to draw a line from D to B. Now I could have gone from A to C. As a matter of fact, I'm going to go from A to C later on in this very example. So it doesn't matter which one you do first. I chose to do this DB or BD line first. I could have gone for that one first because you're going to cover both of them. And if I've got that diagonal in, I've now created some triangles. Now I'm going to show that this triangle here and my triangle over here are congruent. They are identical. To do that, I'm going to have to use one of my tests. Now when I look at my triangles, there are no right angles, so I can immediately rule out this option down the bottom here. I don't know 3 side lengths, I can rule out that one. I don't know 2 side lengths, I can rule out that option. I've come down to this option here, angle, angle, side. Do I actually have side lengths that match up? Well, I do have one, and we're going to discover that in a moment. So the first thing we'll do is we'll actually look at the 2 triangles that we've created by putting my diagonal line through here. Now I'll mark the triangles in green and orange, so we can see triangle ABD is green and triangle BCD is in orange. When I look at those triangles, do I have any angles that match up with each other? Well, I do. I've got angle ADB, which is this angle here, and angle DBC, which is this angle here. Those angles match up. ADB, this angle ADB, A to D to B, and angle DBC, DBC. So I've got those 2 angles that match up, and the reason they match up, because I've got parallel sides. Hopefully you can see I've got a Z shape happening there. Z shape means alternate angles exist. So I can say that those two angles, ADB and DBC, are equal to each other because they are alternate, since AD and BC are parallel sides. Now, I've got other angles that match up as well. If I look for other angles that match up, I'll end up with CDB matches up with angle DBA. So let's have a look at that. C to D to B, CDB. So that's that angle there. Angle DBA, D to B to A, so that's that angle there. They match up. I've got AB and DC are parallel. Hopefully you can see a backward Z shape happening there. And that would mean those two angles are equal. They are alternate because you've got CD and AB parallel sides. So I've got my two angles. The two blue angles and the two red angles match up with each other, two pairs of angles. What I need now, if I'm going to be using this test over here, is a side that matches up. Well, I do have a side length that matches up because if you look at the green triangle and the orange triangle, there's a common or a shared side between them. The distance from D to B is the same for both triangles. So that actually means D to B is a common side on both of those triangles. Well, I've just used angle, angle, side and shown that two angles match up and a side is common. So that means that my green triangle is congruent to my orange triangle because I used angle, angle, side. Well, that's good. Now, this next step, we're saying that DAB, this angle here, and DCB, this angle here, so DAB, D to A to B, there we go, DCB, D to C to B, that one there, they're equal because they're corresponding or matching angles in the congruent triangles. Up here I said those triangles are identical, the blue and the orange triangle. So all three angles match up and all three sides match up. So because I had the two red crosses and the two blue circles matching up, the third angle must match up because the triangles are congruent. They're identical. They share identical angles. So I can finish off by saying that those two angles are the same. And guess what? Those two angles, if I look at the big original parallelogram, those two angles are opposite each other in the parallelogram. And it says, prove that opposite angles are equal. The opposite angles in the parallelogram are equal. There they are. So I've gone through and shown that this angle down here at A and this angle up here at C, they're opposite to each other in the parallelogram. They're equal. Well, what I need to do next is show that this angle and this angle are equal. And the way we do that is we actually have to draw in another line. Now I drew in the line D to B. If I drew in the line from A to C, I could go through the exact same process. I'd end up with a Z shape, and I'd end up with those being the same, and I'd end up with a common side AC. Well, you don't have to go and re-explain the whole thing again. What you can do is you can use the word similarly. That means doing exactly the same as what I did before. Triangle ACD, which is this triangle, this triangle ACD, triangle ACD, and triangle ACB, this triangle down here, they will both be congruent using angle, angle, side, following the exact same pattern. That's what similarly means. Use the angle, angle, side technique and the same processes up above to show that those triangles match up perfectly. And if those triangles match up perfectly, then all three angles match up. So angle ADC and angle ADC and angle CBA match up perfectly because they're matching angles in the congruent triangles, and they're also opposite sides of my parallelogram. So what we can say is opposite angles of a parallelogram are equal, because we found it by drawing triangles and playing our congruence game. Okay, so for this example, part B, we've been asked to use the property, that means a rule, that the opposite sides of a parallelogram are equal to prove that a rectangle with all angles 90 degrees has diagonals of equal lengths. Remember, a rectangle is a special type of parallelogram. So let's draw a rectangle first. Now we have to use the property that all of the sides are equal, and that's what these little dashes, double dash and single dashes are for, saying that the opposite sides are equal. And we've got 90-degree angles floating around, so all angles are 90 degrees. So we've got those. So let's actually go and have a look at what we can do. Let's draw in some diagonals, because the question says we have to show that the rectangle has diagonals of equal lengths. Well, by doing this, I've created lots of triangles. I've created a triangle there, 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 there. There's a heap of triangles here. Which ones do I want to focus on? Because I want to break it down into using the triangles and my congruence proofs for triangles. That will work nicely. Well, what I'm going to do is I'm actually going to use these triangles here. I'm going to use this triangle, ABD, and the triangle ABC. I could use any of the right angle triangles because they're going to be the easiest ones to use. So that's what I'm going to use. So let's consider ABC and ABD. So hopefully you can visualize those triangles. It's this one and this one. Let's look at the sides. Now, if I look at both of my triangles, let's just draw them in again. There's ABC. Oops. This is ABD. This one here is ABC. There's my two triangles that I'm considering. Notice they both share a common side along the bottom. AB is common, so it's a common length. Each of the triangles have a 90-degree angle in them, don't they? This triangle over here, 90-degree angle. Triangle on this side, 90-degree angle. So they both have 90-degree angles. So we've got angle ABC and angle BAD, both right angles. And also, if you look at the right angle triangles, I've got this length and this length are both the same because they've both got double lines on them. They're opposite sides of the parallelogram, which in this case is a rectangle, and they're equal. So AD equals BC because the opposite sides of the parallelogram are equal. We're told that up here. Well, that means by using side angle side that those two triangles are congruent. Triangle ABC is congruent to triangle ABD by using the side angle side method. Well, what does that actually mean? Well, what it actually means is this. If those two triangles are congruent, that means that they are identical. That means that their sides match up. And if I was to look at my sides, on one triangle I've got that length, on the other triangle I had that length, and they match up, and they're also the diagonals. So that means that those two lengths, AC and BD, match up because they're the matching sides on my congruent triangles, and they're also the diagonals in my rectangle, so the diagonals in the rectangle are equal. For example 2, we're asked to prove in part A that if the opposite sides of a quadrilateral are equal, then it's a parallelogram. Well, if we're going to end up with a parallelogram, I'll just start by sketching a parallelogram with opposite sides equal. That's what the single and double dashes mean. So prove that if the opposite sides are equal, so we're told they're equal, that it's a parallelogram. Notice that we've actually got a diagonal drawn on. So this is the question that the diagram you've already been given in your booklet. What we will do is put some labels on it. So A, B, C, D in that order. It doesn't really matter what letters or what order you put them in, as long as you've got something to label your diagram with. Now, if we look at our diagram, let's consider these two triangles, ABC and ACD. So let's look at them. ABC, this one, and ACD, this one. So they're the two triangles I'm considering. Let's look to see if there's any common sides with them. And I could do this if you wanted to. ABC, it just makes it a bit messy, but there's one triangle. Here's the other triangle. So do we have any sides that are common length? Well, yeah, we do. We've got these two because they've got a double dash, and these two because they've got a single dash, and this length is a common length. So actually all three of them match up. So we've got A to C is common. We've got AB and DC are common because they've both got a double dash. And we've got AD and BC are common. They've both got the single dash. So they're the same length as well. So we've actually got, using side, 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 two congruent triangles. So let's just double check though. What did the question want us to do? It says prove that if the opposite sides of a quadrilateral are equal, then it's a parallelogram. So just because we know those two triangles are identical, does that mean that we know that it's a parallelogram? Well, let's think about this. Angle BAC, this angle here, and angle ACD, this angle here, have to be equal. Because if I've got congruent triangles, that means their angles match up. And if I look at this particular one here, see how I've got a Z shape? If those angles match up and that's a Z shape, then the sides are parallel. Normally we have parallel sides mean the angles are the same. Here we've got the angles are the same, which means I've got parallel sides. There's my Z shape. So because those two angles are equal and they match each other in congruent triangles, we can say AB and CD are parallel because alternate angles were created by having those equal to each other. Also, we could go down this path. We could say BCA, which is this angle, and CAD, which is this angle, so those two angles. They're also equal, and if you look, you can see Z shape there on the angle, backwards, but on the angle. So if those two angles match up with each other, you've got alternate angles that exist there, which means that these two sides are parallel. So AD and BC are parallel. Now, if I have alternate angles that exist in both situations, then my sides are parallel, and the question says, prove it's a parallelogram. Well, the definition of a parallelogram is opposite sides are parallel, and if opposite sides are parallel and they're also equal in length, then we know it's a parallelogram. And the reason, go back, these Z shapes mean that these sides are now parallel. This Z shape means these sides are parallel, and because you've got all those parallel sides, we have a parallelogram. Let's try part B. Prove that if the diagonals of a quadrilateral, a four-sided shape, bisect, remember that means cuts in half each other at right angles, then we've got a rhombus. Let's see what we get when we draw a diagram. We know we have to end up with a rhombus, so we're told the diagonals of the quadrilateral bisect each other, so here are my diagonals. There's one, there's the other, so there's my two diagonals. they bisect each other, and that's why I've got the little single dashes and double dashes to say that they're now cut in half perfectly. There's equal length on either side, and if they bisect each other at right angles, so we've got a right angle there, we've actually got right angles in each of those four angles, prove it's a rhombus. Now, if you look at this particular question, you can see that I've got a lot of triangles that I've created. I've actually got 4 right angle triangles in there because remember, these are right angles as well. I've got 4 right angle triangles in there. Now if I've got 4 right angle triangles, let's have a look at them. It's a right angle triangle there, and it's got a single dash and a double dash side length. Here's a right angle triangle here, and it's got a single dash and a double dash side length. Right angle triangle here, one of the sides has a single dash, one of the sides has a double dash. My last triangle has a right angle, one of the sides has a single dash, one of the sides has a double dash. So we can use side angle side for every single triangle, and we've got 4 identical triangles then. So we can see that there are 4 triangles that all have 90-degree angles, and each of them have a single dash and a double dash side length, so they're all going to match with each other. So I can just go by SAS triangles. Those 4 triangles are all congruent. Triangle ABE is congruent to triangle BCE, which is identical or congruent to triangle CDE, which is identical or congruent to triangle ADE. Now I can't start by writing this. I've written here and said, look, I've noticed that there's a right angle and the single dash and double dashes match up, so by SAS, that is true. So I now have a whole lot of triangles, right angle triangles that are identical. Now if they're identical, that means because every one of those little triangles has a single dash and a double dash, they also all have a third side, and those third sides must all match up. So I'll just put triple dashes there just so I've got a side. It means A to B, B to C, C to D, D to A all match up because they're all in the congruent triangles and they're the third side. They're all the hypotenuse, if you like, of those right angle triangles. And if they're all the same length, well, that means we have a rhombus, because what's the definition of a rhombus? A rhombus is a shape that has 4 sides that are the same length. Special type of rhombus is a square because there's all right angles, but this is a rhombus because we don't have right angles at each of our vertices or at each of our corners. So there you have it. It's now time for you to have fun and do some questions. Woohoo! Go for it.